So good morning, I'm Yoram Bachach. I'll be demonstrating crowd IQ. So it's been long known that the aggregated opinions of several people is much better than the opinion of just one person. But there are lots of questions that relate to this topic. So we've designed an experiment called crowd IQ, which was designed to answer these questions. So first of all, how many opinions should you aggregate to have a good performance? How should you perform the aggregation? By what means? Who are your best workers? How do you find them out? How should you compensate them? And essentially, we wanted to know whether the crowd is actually more intelligent than its members. So to do this, we've used a well-known IQ test, literally an IQ test, called Raven's progressive matrices, which is shown here. Essentially, there's a matrix of 9 shapes, one of which is missing, and you have several options for an answer, only one of which is correct. So generally, the population is different in its ability to answer these questions, roughly following this bell curve shown here. So let me show you the system itself. In this test that we've designed, people are asked to answer questions from this well-known IQ test, either alone or in a team with other friends. So they see the matrix here. They just get to click on whatever they think the right answer is. I'll just take a random guess now. And once they've answered many of these questions, we obtain a data set that consists of the answers of many individuals to these questions. Now, given these answers, the question is, how should we aggregate these and what results should we expect to get? So let me show you some of what we've found. First of all, the easiest way to aggregate the answers of many individuals is simply by voting. So if we have lots of individuals that gave us very similar answers to question 1, almost everybody here says the right answer is A, and only one person, David in this case, says the answer is B, we can pretty safely assume that the answer is A, just by the majority's vote. By doing the same for each of the other questions, we obtain a questionnaire that was answered by the crowd. And we can score this questionnaire similarly to what we do with a single human subject taking an IQ test. And this is the crowd's IQ. So by using this very, very crude tool, we can actually aggregate the opinions of a lot of people into one giant mind that answers the questions. This plot shows the performance that we obtain for different crowd sizes, starting from only one person to 100% of a crowd of 100 individuals. So a pretty big crowd. And as you can see, the IQ of the crowd greatly increases, but it saturates at some point. And the question that we've asked is, can we do better by using a mechanism that is slightly better than just majority voting? So we did do that. We used infer.net, which is our Microsoft infrastructure for graphical models, a machine learning infrastructure that allows answering various questions, including this one. In our model, we essentially assume that there is only one correct response to each question, but people differ in their ability to answer the question. Using the infrastructure, we try and estimate both the abilities of the various individuals and the correct answers to the questions at the same time. So the result we get is a nice increase in the crowd IQ by using this machine learning infrastructure. Generally, in Microsoft, we think that we can use it for various means. For example, in Bing, we want to see whether changes in our search engines actually is an improvement or actually has made things worse. So we can ask this question, and we have several people that answer this question. By aggregating this using very, very similar means, we can test for improvements in our search engine. Thank you.